Hey everybody, welcome to the shop. I'm Jarrell. Today we're going to be going over kinematics problems from physics. Now we're not doing any that involve calculus. These are all going to be algebra-based problems. Calculus will come in a different video. But what I want to focus on, even if you're in calculus, these videos are probably really good to start with. We're not going to be using a single kinematics equation. Everything is going to be done from the velocity graph. Now, generally speaking, before you learn the equations and start typing things, not typing things in, but plugging numbers into equations and working things out that way, I find it's far better to look at the velocity graph, and it forces you to understand what each thing is. Do you really know what acceleration is? Do you really know what displacement is? And that's how we're going to solve these problems. So buckle up, get ready. It's going to be a good time. We're going to do about 3 or 4 of them. Here we go. Okay, this is where the rubber meets the road. We're going to solve our kinematics problems, and we're not going to use any equations. We're just going to use a velocity graph. Now, to reiterate, the reason we're just going to use a velocity graph is because everything is on there. The acceleration's on there, the velocity's on there, and the displacement's on there. So let's get started. Here we go. A particle is at rest. That means the initial velocity is 0. Okay, it's at rest. It moves along the x-axis. So you have to remember, there's basically like a horizontal line. There's a particle that's on it, and it's moving in one direction. Okay, either left or right, or maybe it's moving left. Now, the problem tells me it has an acceleration of 4 meters per second squared for 5 seconds. So, let's see what we got. Find the velocity of the particle at t equals 5 seconds. So here we go. Here's what we're going to do first. First, we're going to sketch a velocity graph. Now, it's sort of important here, this is v, this is t, that you don't get too fancy with your sketch. It's just got to be pretty much right, okay? You don't need graph paper. You don't have to count out every little line. You'll see what I mean. But this does require that you know a little bit of algebra, okay? Algebra 1 really is what you need to know. So, find the velocity of the particle after 5 seconds. Well, we know it starts from rest. We know it's got an acceleration of 4, so that means the line is going to have a slope of 4. So I just need to draw it like that. It doesn't have to be precise. And then we know we're going to stop this at 5 seconds. We're going to look at it at 5 seconds. Okay? So that's 5 seconds. Now, what does it mean? Pause the video and ask yourself what it means to have an acceleration of 4. Okay, that means since acceleration is the slope on the velocity graph, because acceleration is the rate of change of velocity, every 1 second, the velocity is going to go up by 4, right? In 1 second. In another second, it's going to go up by 4 again. In another second, it's going to go up by 4 again. Okay, and that's going to keep on happening. And it's going to happen 5 times. So essentially, you've got 5 sets of 4. So what does that make? So we know this is 5 along the time axis. It's 5 seconds. This is going to be 5 times 4. It's going to be the change in x multiplied by the slope, because you're doing 4 increases for every second. There's 5 seconds. So this is 20. Now, what does that stand for? It's 20 meters per second, because notice this is a vertical line segment, and it's along the y direction with v. So 20 meters per second is the final velocity. First question answered. Okay. Now let's take care of the displacement. The displacement, as we discussed in a previous video, is nothing more than the area under the velocity graph. But notice in this case, the velocity graph just makes a triangle with the t-axis. So all we have to do is figure out what the area of that triangle is. And that would be 1/2, the area of a triangle is 1/2 the base times the height. And that's equal to whatever the area is, right? So in this case, 1/2, the base is 5, the height is 20, and that's going to be equal to our area, which is actually going to be equal to our displacement. In other words, what I mean when I say displacement is how far the object is at the end of the time compared to where it was when we started counting. So 5 times 20 is 100, and half of that would be 50. So we know that our displacement is going to be 50 meters. There you go. Question number 2, or part B, is down. Now, if we assume that the initial position, I want to talk about this one. If we assume that the initial position was 12 meters, we want to find out what its position is. Now, that's a different question than its displacement. Its displacement is just how far did it move, and we know it moved 50 meters. So if you think about it, if this were the x-axis and this was 0, right? It's saying the initial position was at 12 meters. It was already 12 meters on the right. And then it moved over the course of these 5 seconds. We know that it moved 50 meters. So where will it be? Well, that would be 62. All we have to do is add the initial starting position to the displacement. Problem number 1 done. No equations required. Let's get on to the next one. Here we are with problem number 2. We're going to solve this without using any equations. Let's go. So, a particle is moving along the x-axis with an initial velocity of 6 meters per second. So, let's draw our velocity graph to get started. This is v, this is t, and now the initial velocity is 6. So you don't have to be crazy with you have to go crazy putting all the little dash marks in there, or drawing this on graph paper or anything like that. This is 6. So now we know that's 6. And the unit's meters per second. So I'm leaving the units off. Maybe I shouldn't do that, but I'm gonna. All right, it experiences an acceleration of 2 meters per second squared for 4 seconds. Now, since acceleration is the slope on a velocity graph, here we go. It's pointed up. Don't have to be too careful with that. Bring this down, and we know that this is 4 seconds. All right, so let's see what we got. Find the velocity of the particle after 4 seconds. So, here we go. Bring this straight over. Okay, so we know that that's 6. Now keep in mind, as you're doing this, you're really just working with shapes from geometry that you already know how to deal with. Right triangles and rectangles. The vertical lines represent velocities, the horizontal lines represent times, and the area underneath it represents displacement. But all we're doing is messing with shapes. That's what makes it so cool. All right, so we know that this is 4 seconds, and we know that this is 4. Now, since the slope is 2, that means this has to be 8. All right. Now, if you don't know exactly why that is, go back in the video a couple of minutes and look, because I explained it back there. All right, so here we go. What I want to figure out first is I want to know what the velocity is at 4 seconds. So the velocity at 4 seconds would be this vertical line right here. And the total length of that line would be 14. So that's 14 meters per second. Part A, solved. Let's go to part B. Find the displacement of the particle. Well, the displacement of the particle is the area underneath. So it's all this. Okay? But that shape looks complicated, but if you actually think about it in terms of it being a rectangle and a right triangle, it's not that bad. So let's find the area one piece at a time. The area of the rectangle on the bottom would be 24, 6 times 4. And the area of the triangle on top, I'll write that over here. 1/2 the base times the height is equal to 16. So this area up here is 16. Now I know, let's add those up to get the total area. 24 plus 16 looks a lot like 40, and the unit would be meters. So now I know the displacement is 40. Now keep in mind, the displacement is not where the particle is. All right, so let's talk about that for part C. The whole time this particle was moving along the x-axis, so it's moving on a horizontal line. Now, if this is position 0, part C says, hey, the particle started at position 10. So it was here at 10 when we started. And note, it was already moving at 6 meters per second. That was the initial velocity. And now we know after 4 seconds, we know the displacement is 40. So what does that mean? That means from 10, it moved ahead 40 meters. So where would it be now? 40 meters to the right of 10 would be at 50 meters. So that would be the answer for part C. This would be the answer for part B. And that would be the answer for part A. Wow, look at that. No equations in sight. All right, hey, we're going to stop the video there. Next video is going to have more problems. I'll try to fit 3 or 4 of them in there. But remember, these problems are really cool. You're just using basic geometry, basic algebra to solve some pretty complicated physics problems. All right, keep going.